So last time was discussing how to model the three-phase induction machine in the ABC reference frame. And if we recall here, in the ABC reference frame, which is the actual frame, we have the voltage equation.
صار معمول سكرين للشاشة.
Okay. Okay. So last time was discussing the modeling of the three-phase induction machine in the ABC reference frame, and we stated that in the ABC reference frame, which is the actual frame of the machine, we have the voltage equation. The first one was for the stator. Who can give me the voltage equation for the stator? Who remember that? V A B C S, S stand for the stator, will equal R S I A B C S plus d by dt of lambda A B C S. This is for the stator, the voltage equation for the stator circuit. And what about the rotor? Who can help me with the rotor circuit?
VABCR.
Okay, so VABCR dash referred to the stator will be RR dash
IABCR dash
ABCR dash plus
lambda
dt of lambda ABCR dash, and dash refer that or indicate that the rotor quantity is referred to the stator. So from now on, if I forget to or omit using the dash, it's already understood that the circuit is referred to the stator unless I'm telling you this is not. Then after that, I think we evaluated the electromechanical torque. Good. So here we can write the electromechanical torque, or the torque, the machine torque, and simply TE, which was a function of I comma theta r. We use the co-energy in order to calculate. It was d omega c, and omega c was a function of I comma theta r over d theta r. Now this factor comes from where? From the equivalency between, or the relation between the and. Now recall that in general, if I need to calculate the torque, it will be partial omega c with respect to partial theta Rm when I kept constant. Now theta Rm is the mechanical angle, and theta r is the electrical angle, and theta r is the electrical angle. and the relation in between is the number of the pole over 2. So simply, last time I think we highlighted that theta r m is equal 2 over p theta r, where p is the number of machine pole. Yes. And because we assumed the system is magnetically linear, then omega c will equal to omega f. And simply it was very simple to evaluate 1 over 2 IABCS transpose LS IABCS, then plus IABCS transpose LSR dash IABCR dash, and finally the self-inductance or the energy due to the rotor circuit 1 over 2 IABCR dash LR dash, this here transpose IABCR dash. Now also, if you recall, we stated that LS and LR dash are constant function of geometry, correct? Function of geometry. So simply, if I need to evaluate the torque, I don't need to take this term and this term. The only term that I need to evaluate, because the inductance and the rotor is function of theta, correct? L S R dash. Yes.
معلش أسأل سؤال.
تفضل.
الترم الأول LS هسا أنا بقصد فيها الليكج والماجنتايزنج الاثنين مشمولين ضمن الأوميجا فيلد.
Now, even if I include here the LLS plus LMS, which I'm including all, although this one has no relation with the field energy, this I'm not taking to. I'm not.
Yes. Yes.
This one does not include the LLS. This one is the mutual inductance, and by the name, the mutual inductance is what? Is the flux which generated, or how much flux is generated by a coil which link the other coil. So by definition, this one does not include the leakage inductance.
Yes.
Did I answer your question?
Yes. Yes.
Good. So if I do the math, simply I need to evaluate the torque. So I will say it's P over 2. Then I will differentiate the co-energy. The only term I need to differentiate is the term inside the dash red box here. So this will be the IABCS transpose partial by partial theta r LSR dash IABCR dash. And I think last time we stopped here. Yeah. So if I need to write, if I need to expand to do the math, to find an expression for the torque, and I think you did that because if you need to simulate the machine in the ABC reference frame, you need to evaluate the torque. So simply you need to find an expression, let's say, for the torque. Let's assume that I did the math, I expand, I differentiate, I multiplied, I collect the term. So simply the torque will be equal to minus P over 2 LMS multiply by, let's put the first term here, IAS IAR dash minus 1 over 2 I R dash minus 1 over 2 I C R dash. Then let's take the second term plus IBS multiplied by IBR dash minus 1 over 2 IAR dash minus 1 over 2 ICR dash plus ICS ICR dash minus 1 over 2 IBR dash minus 1 over 2 IAR dash, and we did not finish yet. Those all multiply by sine theta r plus square root of 3 over 2 IAS IBR dash minus ICR dash plus IBS ICR dash minus IAR dash, I did not finish yet, plus ICS IAR dash minus IBR dash, all multiplied by cosine theta r. Now, why I did write and the expression or the exact expression for the torque? Simply, if you notice here, can I use this expression to control the machine? Or can I have useful information from the torque? Which component I need to control? Should I control IAS? Should I control IBS? Should I control ICS? What about the rotor circuit? So simply, if you notice here, the expression is complicated, highly nonlinear, and simply has no physical meaning, let's say, or not physical meaning, no, but simply there's in sense of control, I cannot use it to control the machine directly, or simply this expression will never give me a way in order to simplify the control problem of the machine. In the end of the day, I need the model, not only for the model itself. I need the model in order to analyze the system, to understand the system. And the second stage, I need the model in order to control or design a controller for this system. So can one tell me from this expression, which component or which component, if I change, the effect will be what? Huh? Yeah. Maybe network problem, but whatever. Okay. Did you see the exact expression for the torque?
Yes.
Yeah. This one here. Do you see it?
Yes. Yes.
Yes. So can you give me or do you think that it's easy to understand which component I need, or which current, or which term, or which terms I need to control or change or manipulate in order to achieve certain torque? Let's assume the machine demand now, due to the load, in the end of the day, the machine will provide a load corresponding, will provide a torque corresponding to the mechanical load connecting to the machine. So let's assume that for this instant, the machine demand 10 Newton meter, let's say, torque. How I can do that? Or let's assume that I need to change the speed from 100 radian per second to 150 radian per second under load or under no load. In the end of the day, I need to control the torque. So in order to control the torque, I need to control the currents, correct? But simply this expression is very difficult, highly nonlinear. This one linear or nonlinear, by the way?
non-linear.
Nonlinear. Why nonlinear?
فيها sine وفيها
Yeah, because it has, okay, sine and cosine, and it has two states multiplied by each other. Here you have the current IAS multiplied by the current IAR. So simply this means that this system is nonlinear. So even though when you did the simulation, you used the first equation, the voltage equation, then you build the electromechanical torque, and finally you go to where? To the swing equation or the mechanical equation of motion, and this will end, let's say, the mathematical model of the induction machine in the ABC. Simply you will say that you will TE will equal J, which is the inertia, 2 over P partial omega r or d omega r by dt plus 2 over P B omega plus TL, which is the load torque, or whatever you did write it in the Do I have a connection problem?
Yes
يس
دكتور.
دكتور ممكن تعيد
دكتور ما بنسمعك.
Okay. Now, I did say that
هو في
while
مشكلة بالتيمز نفسه.
okay.
بالمكان.
Okay, let's try to do our best. Huh? This is our resources. This is what we have. So let's optimize what we have. So what I was saying is that while you are simulating the machine in the ABC reference frame, you needed the voltage equation, the torque equation, and the swing equation, correct? Yes?
yes تمام.
And simply you know that this term is the inertia, yeah? The rotor inertia, let's say. And simply it's given in kilogram meter square. And this term here okay, just a minute, let me take a call, then I will return back to you. Okay, sorry for that. And B is the viscous friction. And this one is Newton meter second per rad. And if this is the case, if you notice here, I'm using omega r, not omega rm, because I'm using the factor, which is the 2 over b. Yeah? Simply this one, if I need to write it in term of the mechanical speed, it will be TE will equal J d omega rm by dt plus b omega rm plus TL. Simply someone say that in general we are rearranging such that this one can be written as J d omega rm by dt plus b omega rm should equal the net torque or the summation of the torque, which is the TE minus TL. And I think you did that, huh? In order to simulate the machine. And I hope you pay attention for the number of the poles, or the difference between the electrical speed and the mechanical speed. And I will recall that the mechanical speed is the something that we can see, the mechanical rotation. One rotation is 2 pi. Yeah, the electrical speed is something else. How many times the flux change its priority? Let's say north, south, north, south. So this one, how many poles I'm having here? 4 poles. So simply this means that the electrical speed is twice than, or twice faster than the mechanical speed. Yeah. Good. So now this will, let's say, pave the way for us to discuss, is there any transformation that we can use in order to simplify the complexity in the machine, in the modeling of the machine, of course. Now, let's recall, or I will ask question, and if you can answer, please. The main complexity of the machine came from where? The model, huh?
الكرنت دكتور انهم مضروبين في بعض.
If you notice, the most difficult thing that this one was not constant, it was function of time. Yes? And if you have one matrix function of time in the system, this will be called time varying system. Huh? You know that in general, the system we have linear, we have nonlinear, also we have linear time varying, we have linear time invariant, and also the same thing for the nonlinear system. So the most difficult thing is that the matrices, or the LSR, is a function of what? Of theta r, which is a function of time. Yeah. This will cause, let's say, the nonlinearity in the system. So can we have a transformation or a change of variable in order to simplify the calculation or the complexity of the machine mathematical model? And we will try to answer this question in this lecture, inshallah. So I was, yeah.
بس لو نرجع على شغلة.
Yep.
معادلة التورك الأولى الماتريكس اللي هي مثلا مشتقة ال LSR. ليه يعني غلط؟ ما فهمت بالضبط ليه غلط إنه ندخله على الماتلاب.
I did not say it's a mistake to do it in MATLAB. By the way, the MATLAB is high computational language which can evaluate even the partial derivative of matrix. Yeah, but if you need to write an exact expression for the torque, this will be the exact expression for the torque. Now, if you are, let's say, have the skill to deal with the matrices in the Simulink, this will be a good thing, by the way, because the machine model will be compact. Yeah. But not all of you, I think, has the skill to do matrix calculation in Simulink. But I did not say it's a mistake. It's not a mistake. This one and this one are the same. But this one is what? Is expand form, let's say. This one is compact form. Yeah.
طب دكتور في مجال إنه إذا أنا ما طلع معي صح إنه تشير معنا الحل إنه أشوف إيش المشكلة بالضبط.
Yeah, I will do that. I will do that. We'll check all of your simulation and I will contact you regarding if there's any question or concern or correction. Okay? So now we will discuss the reference frame theory. Now, the reference frame theory is what? Do you know the change of variable? It's actually a change of variable. You know the change of variable, yeah? In the calculus, we did that. In the control, we did that. In the signal system, we did that. I think in circuit 2 also we did that. So the change of variable is often used to reduce the complexity of the machine mathematical model. Which mean the ABC model. Now let's return to the change of variable or the reference frame theory. Who can define the change of variable, or what's the meaning of the change of variable? Or anyone can give me example of change of variable? Anyone? Should I ask? أمينة؟
دكتور مثلا زي الستيت، مثلا لما اخذنا باللينير لما يكون عندي ماتريكس اضربها بماتريكس ثانيه عشان اعمل مثلا diagonal ماتريكس x equal to
It can be that. So simply, it's a transformation, yeah. But simply now, this example, someone of us feels not something we all the time do that. Do you know Laplace transformation?
Yes.
Laplace transformation is a change of variable, yeah. I'm transforming the system from the time domain to the S domain, yeah. I'm transforming the system from physical domain, which is the time domain, to artificial domain, which is what? The S domain. By the way, the S domain is artificial, not actual domain. Then why we did that? Why? Because simply why?
Easier. To make it easier and linear assumption يعني by assumption إنه نفترض إنه system linear نستخدم اللابلاس.
Simply, yeah, the Laplace is applicable only for linear time invariant system. That's correct. But simply, why we are interested in Laplace, because Laplace will transfer the linear time invariant system, the ordinary differential equation, to a set of algebraical equations. So now, just imagine, dealing with algebraical equation is more easy than dealing with what? With a differential equation or ordinary differential equation. After finding the solution, this solution is useless unless I'm having what? The inverse Laplace transformation. Yeah? Why? Because in the end of the day, I need to provide my solution in the physical domain, or in the actual domain, in the time domain. The same thing here. Now, what I will try to do, I will try to have a virtual transformation in order to transfer the actual system, which is the A, the B, and the C into another coordinate, into a virtual coordinate. Why? Because this coordinate, I can see something else. I can look to the problem from another point of view. In this case, I can simplify the difficulty associated with the mathematical model if I deal with the model in the artificial coordinate, not or compare the coordinate or the ABC. Now, if you remember, when we discussed did I regain the connection?
Yes.
Okay, so let me pair the connection with my telephone. With my mobile, I think this will give me more. Let's see. Establish. Just wait a minute, huh? I will change my connection just. Okay, now let's hope the connection now is better than the previous one. Okay, so we was discussing the reference frame theory, and simply we stated that the reference frame theory is nothing more than a change of variable that we will use it in order to reduce the complexity of the machine mathematical model in the actual system, and we cannot do that unless we have the transformation and the inverse transformation. And simply this is called the QD reference frame, or if we recall.
دكتور الكونكشن
Can you hear me?
دكتور صوتك قطع كثير.
I don't know. Okay. Now is it okay?
No.
Okay, just a minute. Okay, just a minute. Okay, I think now the connection is more stable. Okay, now can you hear me and see my screen?
دكتور معك.
Okay. So let's discuss the reference frame theory, and we stated that the reference frame theory is a change of variable which is used to reduce the complexity of the machine mathematical model, which is the ABC reference frame. Now, if we recall in the previous lectures, when we discuss the basic principle of the electrical machine, we stated that if I need to generate a torque, at least I need two coils, correct? When we have a single coil, that was depend on the, let's say, the geometry of the machine, salient or non-salient. And even the non-salient, it will generate pulsating torque, and this torque all the time will be, or the average value for that torque will equal to 0. So in order to generate a torque, I need at least two coils. So this is actually what we need. I need to assume that I'm having a two coil, and those coil, let's say, pointed toward, one is the quadrilateral axis, so this will be the QS, and 90 degree behind this one will come the dx, or the direct axis. This is the ds. And let's assume for now that this frame is rotating by arbitrary speed, omega. Now this speed until now is not specified. If I specify this one to omega 0, this will be the stationary reference frame. If I specify this one to omega r, this will be a reference frame fixed to the rotor. But simply let's highlight the meaning of the reference frame and how I can use the reference frame. Now, the angle between the Q and the D is pi over 2. And the angle between AS and the QS, this one here, is theta. And we know that theta is what? Theta is what? Is the integration of omega d tau plus theta of 0 if I'm having initial angle, correct? Now, what I'm trying to do...
Theta هي rotor angle.
No, not, this is not theta r. This is theta associated with the speed, huh? Yeah? If this one was omega r, this will be theta r. Yeah? Now here, this speed is what? Unspecified. This is called the arbitrary reference frame. Here, omega is unspecified. So simply, this actually will call the arbitrary reference frame. I'm assuming that my reference frame is rotating by arbitrary speed. I'm not fixing the speed. Yep. Good. And let's assume that here I'm having a quantity, let's say FAS, FBS, FCS, and I need to find its projection in the direction of the Q and the D. So simply what I'm searching for, I'm searching for a transformation such that given F, A, B, C, S, I can get the F, Q, D, S, let's say. And here I need a transformation, and this transformation I called K, S, the transformation matrix. So simply here I need to find this transformation matrix. And of course, I need the transformation to be one-to-one and invertible, which means that I need also to find, given F, Q, D, S, I can calculate the actual variable in the ABC reference frame, F, A, B, C, S. So I need also to find KS inverse. Yeah. So in order, you know, F here is any function. It can be flux, it can be voltage, it can be current. Yeah. Yes. This we already.
دكتور.
Yep.
الكي اس هي سكوير ماتريكس راح تكون.
Yeah. In order to have the inverse and for the simplicity, I need to assume that this to be square, but simply here I'm having 2, here I'm having 3. So I need to complete the transformation by a trivial one. So here I will use the 0 sequence. So that's why I'm having space here. Yeah? So here, this will be what? A transformation from F, A, B, C, S, which will equal F, A, S, FBS, FCS to FQD0S, FQD0S, which equal to FQS, FDS, and F0S. And F0S is what? Is the 0 sequence. Yeah. So simply here I'm having what? The component in the direction of the AS, the component in the direction of the BS, the component in the direction of CS, and I need to project it in direction what? FQS and FDS, and I need to complete the matrix to be 3 by 3, yeah, because KS here is what? According now to my definition is element of 3 by 3, yeah. So in order to do so, I use what? The 0 sequence. And you know that in any balanced system, the F0S is nothing more than what? 1/3 of FAS, let's say in general it's FAS plus FBS plus FCS. Yes? Yeah? Whatever I change the transformation, this was not changing. Yeah? By definition. Yeah? The 0C. Yes? So now let's see. If I'm having here, and I will recall F can be anything. F can be voltage, current, flux, and so on. So in order to write the thing in compact form. Okay. So now let's see. Here, if I'm having a function which is directed toward FAS, and I need to find FQ of S, what I will do? I need to find the projection of FA of S in the direction of FQ of S. What I will do? Can you project that?
FAS في cosine theta.
Yeah, so simply you are telling me that. Now you will say here, this will be the FQS, this will be the FDS, and this will be the F0S. Now I need a transformation matrix in order to transfer the FAS, FBS, FCS in the direction of FQ and FD. So the first thing here, if we notice, the angle in between is theta. So if I need to project the FAS in the direction of the Q, it will be cosine theta, correct? Yeah. So here I will put what? Cosine theta. Now, what about if I need to find the projection of the FBS in the direction of FQ? It will be what? Now I'm here and I need to find the projection in the direction of Q. The angle in between is what here? This angle is equal to what?
120 ناقص ثيتا.
minus theta.
Yeah, so theta minus 2 pi over 3, yeah, in radian. So this will be cosine theta minus 2 pi over 3. Now the same thing, I'm having three components, one toward the direction of the A, the B, and finally the C, and I need to find its projection toward the Q. So FCS, if I need to project it, FCS, I need to project it toward the Q, then what I'm having, the angle will equal to what? You know that this angle is equal to what?
theta
2 pi.
120
باي اوفر 2
over 3.
Yeah, and this angle is equal what? Another 2 pi over 3. So it will be what? It will be theta
plus
2 pi
2 باي اوفر 3
plus, yeah, it will be 2 pi over 3 plus theta r, correct? Yeah. Yes.
تمام.
Okay. So now this will be the cosine theta plus 2 pi over 3. Yeah. Good. Now, what about if I need to find the projection of the three components, the A, the B, the C, in the direction of the D? So let's see it. Now I am here, FAS, and I need to find the projection toward this one. So this will be what?
Sine theta.
No. Yeah, sine theta. Yeah. It will be sine theta. It will be actually cosine theta minus pi over 2, and this will equal to what? Sine theta. Yeah, thank you. So this will be what? The complement, sine theta. So the second one will be what? sine theta minus 2 pi over 3. And this will be what? Sine theta plus 2 pi over 3. Now the last one is what? 1 over 3. Yeah? 1 over 3. 1 over 3. Yes or no? Yeah? Why? Because the last one we agreed. This is the 0. F0 of S is equal to what? 1 over 3 FAS plus FBS plus FCS has no relation with what? With the transformation. Yep. Okay. Someone will say, if I'm having a transformation, I can scale the transformation, multiply the transformation by certain constant in order to achieve something useful. For example, if I need for a balanced system in the ABC to have the magnitude of FQ of S as a magnitude equal the magnitude of the FAS. In this case, what I can add here? And for that, let's take the following example. Let's assume that we have voltage FAS, which will equal VM cosine, let's say theta. Yeah. And we have VBS will equal VM cosine theta minus 2 pi over 3. And we have VCS, which will equal VM cosine theta plus 2 pi over 3. And I need to find the VQS and the VDS. Yeah. So simply now, VQ of S will equal to what? If I multiply, it will equal to what? VM. Then I'm having what? Cosine square theta. Yeah. Plus cosine square theta 1. I'm too old to write this one, so I will assume that this angle is equal to theta 1 and this angle to equal what? Theta 2. This will reduce the time and the effort. Yep. Then if I multiply, I will get also plus cosine square of theta 2. Yeah. Now, do you know this one is equal to what? If you go to your textbook in the appendix A, you will find the trigonometric relation. You will find that cosine square x plus cosine square x minus 2 pi over 3 plus cosine square of x plus 2 pi over 3 is equal to 3 over 2. Is equal to what? 3 over 2. So this will equal to what? 3 over 2 VM. Yeah. Now, what about if I need to calculate the voltage in the direction of the D? Who can help me with that? VD of S is equal to what? You multiply this one by those vectors. Yeah. So who can help me with that?
VM cosine theta sine theta.
So sine theta cosine theta. Yeah.
Yes.
Plus
Cosine theta 1 sine theta 1.
Now you are multiplying what and what, by the way?
Yeah, second.
Yeah. So this will be sine theta 1 cosine
Theta 1.
Theta 1. Yep.
Plus sine theta 2 cosine theta 2.
Yeah, exactly. Thank you. And do you know this one will equal to what? This one will equal to 0. If you go to the appendix, you will find that sine x cosine x, sine x minus 2 pi over 3 cosine x minus 2 pi over 3 plus sine x plus 2 pi of 3 cosine x plus 2 pi of 3 is equal to 0. So this will equal to 0. So now, if I need to put here a scale, and you know that the scale will shape the result, it will never change the nature of the transformation. Huh? The transformation is still, I'm transforming from ABC to the Q and the D. But now I need to add a scale. If I need to add a scale, and this scale has advantage such that for a balanced system, which rotating in the same speed, by the way, you see? Yeah, I'm rotating with the same speed. Then VQ of S, I need it to be equal to VM. If I need it to be equal to VM, what I should multiply here by what?
2 over 3.
Yeah, I need to multiply it by 2 over 3. But the zero sequence, I don't need to change it. I need to fix it 1 over 3, 1 over 3, 1 over 3. So what I should do now is change. I need, in the end of the day, my F0 of S should read 1 over 3 FAS plus FBS plus FCS. If this is the case, I need to modify those to keep 1 over 3 in the end of the day. So I should multiply it by what here?
1 over 2.
1 over 2, yeah, thank you. 1 over 2, 1 over 2. So this is the how we are building the transformation matrix and the meaning of the scaling here. Huh? Someone will say, I need my transformation matrix VQ of S to be not the maximum value, the RMS value. The RMS value. Yeah. Someone will say, I need to have a transformation which has another useful information. Huh? So this can be done by what? By the scaling factor here. Yeah, by the scaling factor. Okay. Now we fix the scaling factor according to the textbook, which chooses 2 over 3. Why? Because if I'm choosing the scaling factor to be 2 over 3 for a balanced system in synchronous reference frame, which means that I'm rotating with the same speed of the voltage or the system, then the Q will equal the A as a magnitude, and the D will equal to 0. The D will equal to 0, and VQ will equal to what? VM if I'm using the scale 2 over 3. Yeah. Now, you know that without the inverse of the transformation, this transformation is useless because my actual domain is the ABC, not the QD. So what I need to find the inverse transformation. So I need to find the KS inverse. Simply, this is a 3 by 3 matrix. If I do the inverse, it will equal to cosine theta sine theta 1 cosine theta 1 sine theta 1 and 1 cosine theta 2 sine theta 2 and 1. And I will recall that by definition, theta 1 is defined to be what? Theta
minus 2 pi over 3.
Yeah, thank you. And by definition, theta 2 is equal to what?
Theta plus 2 pi over 3.
Yeah, theta plus 2 by 3. Thank you. So theta plus 2 pi over 3. Yeah, good. Now, yeah. Not the transpose, no. It's not the transpose. Simply in the transpose, here you have 1 over 2, 1 over 2, 1 over 2, and here you have what? The scaling factor. But this is very interesting. What about if I need to scale, to design the scale or to reshape the scaling factor such that KS inverse is equal K transpose. So simply here I will write like a question. Find the needed scaling factor such that Ks is equal to Ks transpose. Yeah. How I can do that? Now we know that in general Ks is equal to certain factor here. Let's assume it is alpha multiplied by cosine theta, cosine theta 1, cosine theta 2, yeah, sine theta, sine theta 1, sine theta 2, and simply in the end of the day I need here to scale the zero sequence, because if I change this one, I need to change the zero sequence such that it will be in the end of the day F0S is equal 1/3 FAS plus FBS plus FCS, yeah? But those will never change because those are the projection, yeah? I only change what? The scaling factor. So how to find that? So simply you are saying to me, if I can find such a factor, then I can say Ks inverse or multiplied by Ks is equal to the identity matrix, correct? Yeah. So simply under this assumption, this means that K transpose multiplied by Ks is equal to the identity factor. Yeah. And of course, it does not matter from where I'm multiplying because it's a square matrix. So the same thing, it will be Ks transpose. Yeah. Yep. So now, can anyone find the needed scaling factor, this one? And if I find this one, automatically I will find gamma in order to maintain the F0 of S is equal 1/3 the summation of F. Yeah. ABCS. Yep. So let's assume this is lifted for you to do it by yourself. Yeah. It's not difficult, huh? It's not difficult to do that. Good. Now, if I'm having a transformation and simply I need now to describe my system in the new reference frame, which is the QD reference frame. And let's assume that we will discuss the power, and we will remark about the power and its relation with the transformation. So if I'm having the total instantaneous power, let's assume I'm having a stationary circuit.
دكتور
Yeah.
يعني بس بدنا نعمل أي ترانسفورميشن لازم إنه يعني نضرب أو نلاقي الكونستانت بحيث إنه يكون كي اس الانفرس مضروبة بالكي اس ترانسبوز.
Now, if you following me, I said that this scale, I can adjust it, I can shape it such that to get useful information. Yeah. Now the textbook proposed, or most of the literature said that if you select the scale to be 2/3, then the magnitude in the ABC and the magnitude of the FQ are the same. Yeah. In the end of the day, due to this selection, I will get VQ of S equal V max. Yes? Yeah. Someone will say, can I change this one, or this one is respected? I cannot change it. No, you can change it, of course. But someone will say, if I need to change it, I need to change it due to the purpose. I need to get some useful information. Someone will say, what about if can I change this factor such that the inverse is equal to the transpose? In this case, I don't need to calculate the inverse, correct? You know, the transpose of the matrix is more easy to calculate than the inverse of the matrix, yeah?
Yeah.
So if this is the case, I need to change what? The scaling factor. If I change the 2/3, for sure I should change the 1/2. Why? Because in the end of the day, I need to what? To maintain the zero sequence, which has no relation with the transformation. The zero sequence is only proposed in order to what? To complete the square matrix. Yeah? So if this is the case, I will change the 2/3 to alpha. And simply, in order to find alpha, I will say that Ks multiplied by Ks transpose, which is the inverse, will equal to what?
The identity.
The identity matrix. Now, what I'm asking you to find the value of alpha and gamma.
Okay.
Yes? Is it difficult?
لا احنا بس يعني رح نضربهم
Yeah.
ونطلع ألفا.
Simply, what you will use those identity. This one, you need this one, and you will need this one only. And as I told you that, go to the appendix A in your textbook, you can find a list of the trigonometric relation which most of the three-phase system obeying or we use through this lecture. Yep. Yes. So this one is left for you in order to calculate what? To calculate the alpha and the gamma. Understood what I'm asking you to do? Okay, good. So let's assume that I'm having a stationary circuit and I need to calculate the total power, the instantaneous power. So let's assume that stationary circuit, instantaneous power. So the power in the ABCS will equal to what? Who can tell me the power in the in the stationary circuit equal to what?
دكتور المفروض ما يتغير.
Yeah, which will equal VAS IAS plus VBS IBS plus VCS ICS. Yeah. Now I need to calculate the power in the QD0S. How I can do that? I need to find the relation, the power in terms of what? Of the Q and the D reference frame. Now, this power in terms of what? In the ABC. How I can do that? Huh? Remember, FQD0S equal KS. Yeah?
Inverse.
The FABCS. Yeah? So simply, if the voltage here,
KS inverse في V QD0S أي QD0S في V QD0S.
Okay. So in terms of voltage will equal KS VABCS. So this one, instead of this one, what I will write? I will write KS inverse VQD0S all transpose. Yeah. And instead of this one, what I will put?
KS inverse في I QD0S.
KS inverse I QD0S. So this one will equal to what? VQD0S transpose KS inverse transpose, yeah, multiplied by KS inverse multiplied by IQD0S. Yeah. Now, if I do the math, if I multiply those, I will get BQD0S will equal 3/2 VQD0S transpose or let's make it, because I'm having the zero sequence inside. So this will equal VQS IQS plus VDS IDS plus 2 V0S I0S. Now, this one came from where? From the transformation. Yeah, from the transformation. Now, do you see here, if I'm using the assumption that Ks inverse is equal to the K transpose, in this case, I can write the power in the QD0S as VQD0S transpose IQD0S, correct? If this one is holding, if this relation is true, then this one actually is what? Ks inverse transpose. Yeah, so in the end of the day, this will equal to what? Ks. And this what will be? Ks inverse. So the multiplication of those will equal what? The identity matrix under the assumption of this one, huh? But our transformation is not this one. So that's why I'm getting here what? 3/2, and here I'm getting what? The 2. But whatever I change the transformation, the scaling, if I change, the value of the power will change. The value of the power will change.
لا
Yeah.
لا.
Why? Because simply if I change the power, this means that I'm changing the system. Yeah. If I'm having 1 horsepower in the ABC, if I transform it, I will get 2 horsepower. This will be ridiculous. Huh? This is changing the problem. Huh? The power is not changing under the transformation change. So here I will write a note for you that the total power is independent of the user reference frame. The total power is independent of the used reference frame. Which means that the waveform of the power is the same regardless of the reference frame I'm using. So the waveform of the total power is the same regardless of reference frame in which it evaluated. Good. This is very important. Huh? If I'm changing the reference frame, I'm not changing what? I'm not changing the power. Otherwise, I'm changing the system. Okay. So now if we understand the principle of the reference frame and how we can transfer, let's say, ABC quantity to the QD quantity, let's start trying to transfer stationary circuit, RL circuit in the stator to the QD reference frame. So here, let's start with trying to implement the reference frame theory in a circuit which is RL. Why we are interested in the RL? Because the induction machine, or most of the machine, or all the machine actually, is RL circuit in the end of the day. So this will be stationary circuit variables transform to the arbitrary reference frame. So let's assume that we have RL circuit. Now, the voltage equation of the RL circuit is equal to what?
اللي هي الريزيستنس لوسز بلس الفلكس لينكج من فاراداي لو.
Yeah, so VABCS will equal to RS IABCS plus d by dt of lambda ABCS, yes? And remember, if this one is symmetrical load, then RS is diagonal matrix. So RS, 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 and 0. Correct? Yeah. Now I need to transfer this one to where? To the QD 0 reference frame. What I should do? And here I will write the FQD0S to remember it. KS FABCS. And if I need the inverse, then FABCS will equal KS inverse FQD0S. Yeah. So the first thing, what I should multiply here?
Multiply by KS.
By KS. So if I multiply here by KS, automatically this one will be what? The voltage in the VQD0S will equal. Now here I'm having KS, RS. Now instead of IABC, I need to substitute what?
KS inverse
Yeah, so this will be the KS inverse, the FQD0S plus, here I'm multiplying by KS, then here d by dt, and instead of lambda, what I should put here?
KS inverse في lambda
KS inverse, yep, lambda QD0S. Now, we know that Ks is a function of theta, so it's a function of time. So I need to evaluate this one as a chain of rule, as a chain of rule. So now, VQD0S will equal. Now, because this one's diagonal, I can get RS out, and I will get KS inverse, which is the identity. So this will be RS. This is the voltage. Here, this one is the voltage. V.
current دكتور current.
Yeah, it's a current. Yeah, thank you. It's a current. Yeah. So this will be the IQD. Yep. So now this will be the identity matrix. So RS will be out, which means that the resistance in the ABC or in the QD are the same in the balance system. So this will be the IQD0S plus. Now here I need to use the chain rule. So who can help me with that? The first thing I will say KS. I will differentiate the first one. KS inverse multiply by lambda QD0S plus KS inverse lambda QD0S. Now we know that this one is what?
في d by dt للKS inverse.
No, here I forgetting the d by dt of this.
KS inverse. تمام.
Yeah. Yeah, and this one is what? Is the identity matrix. This one here is what? The identity matrix. So now I end up what? I need to evaluate this one, this term, in order to finish, to find the voltage equation in the Q D reference frame. I need to evaluate this one. And to do that, let's, the first thing, differentiate d by dt of Ks inverse. So this will equal d by dt. Do you remember the Ks inverse was equal to what? Cosine theta sine theta 1 cosine theta 1, or here let's write it theta minus 2 pi over 3 sine theta minus 2 pi over 3 1, and here I'm having the cosine theta plus 2 pi over 3, and here I'm having the sine theta plus 2 pi over 3 and 1. Now, who can help me with differentiating this one?
Minus sine.
Okay, so let's start opening the matrix here. The first one is minus sine, okay, minus sine
And cosine theta.
theta, then cosine theta, then 0, then minus sine, okay, let's say theta 1 because of the space, cosine theta 1, 0, then minus sine theta 2,
Sine theta 2 and
cosine theta 2 and 0. Is that correct? Did I miss something?
scalar or something.
Huh? Did I miss something, or this is one is correct? Theta is function of time, by the way. And if we need to differentiate a function of x, d by dt, this equals to what? Partial f by partial x, x dot, huh? So here what I'm missing? Theta dot, which is omega. Yep. Correct? Yeah. If you need to differentiate the cosine, it will equal what? Omega minus omega sine theta. Yeah. Why? Because theta is a function of time, actually. Yeah. Correct?
تمام.
Good. So now what I need to multiply. I need to evaluate this term. So I need to multiply Ks by the Ks inverse. Correct? So let's do it here. So now I need to evaluate the Ks by d by dt of Ks inverse, and this will equal. Now, if I remember Ks was equal to 2 over 3, then here what I'm having, let's make it more easy to calculate. Here is C theta 1, C theta 2, S theta 1, S theta 2, and I'm having 1 over 2, 1 over 2, 1 over 2. Then I will multiply it by this one. So here omega will come. Yeah. And here I'm having what? Minus S theta. So S is stand for sine now due to the space limitation. And this is the most laziest formula you can find, by the way. Then you have the cosine theta 0, minus sine theta 1 cosine theta 1 and 0. Then you have minus sine theta 2 or minus or this cosine cosine theta 2 and 0, and I need to evaluate this one. So let's multiply the first one, cosine sine. Do you remember the identity I gave you? It was what? It was sine theta cosine theta plus sine theta 1 cosine theta 1 plus sine theta 1 theta 2, sorry, cosine theta 2 equals 0. Equals 0. So the first one is what? Cosine sine, cosine sine, cosine sine. Okay, it's minus, 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 but it will be the same, huh? Multiply this one by minus, you will get what? 0. So the first one here is what? Of course, let's take this one here. The first one here is 0. Yeah. Now the second one. This one cosine square. Cosine theta square, cosine theta 1 square, cosine theta 2 square. Do you remember this one also I gave you? Yes, 3 over 2. Yep. So this will be the cosine theta square plus cosine theta 1 square plus cosine theta 2 square, and this will equal 3 over 2. So here what I'm having, 3 over 2. What else? 0. I don't need to calculate the last term actually. Yeah? It will be 0 because I'm multiplying by what? By a 0 column. Okay. Now the second one here. What I'm having? Sine square, sine square, sine square. This will equal also 3 over 2. So the same thing. Sine square theta plus sine theta 1 square plus sine theta 2 square is also equal 3 over 2. So now what I'm getting? Sine square negative, okay. Sine theta 1 square negative, okay. Sine theta 2 square negative, and this will equal to what? Minus 3 over 2, yeah. So this will be the minus 3 over 2. What else here? This will be what?
0.
0. And this will equal to what?
0.
0. Why? Because it's sine theta 1, sine theta 2, the triangle will close, the resultant is equal to 0. So 0 and 0. So the resultant in the end of the day for this term, Ks, d by dt of Ks inverse is equal to what? Omega multiplied by 0, 1, 0, minus 1, 0, 0, 0, and 0, and 0. Yep. Correct. Yeah. So now I'm ready to write the voltage equation in the QD reference frame. So let's write the voltage equation in the QD reference frame. So to this end, the voltage equation in the QD0 arbitrary reference frame are, so let's try VQ D0S will equal RS IQ D0S plus omega. Here I will define a term, I will call it lambda DQS, and now I'll define plus d by dt of lambda QD0S, and by definition lambda dqs is equal to lambda ds, that's why I'm changing the sequence, minus lambda qs and 0. Good. So this is a matrix form. If I need to write it in expand form, then VQ of S will equal to what? Who can give me VQ of S equal to what? VQ of S.
IQS plus omega lambda lambda QS.
No, lambda D. Omega multiplied by
lambda
D.
DS.
Yeah?
Okay.
Then plus?
Plus the derivative of lambda QS.
QS. What about VDS equal to what?
RS IDS minus omega lambda QS plus d over dt lambda ds.
V0S equal to what?
RS I0S d by dt 0s.
Yeah. Yes. Now let's see. If you remember, when we start discussing the transformation, we said that in general I need the transformation in order to simplify the mathematical model of the system. Now, this one is more simple, I think. Now let's see what's the meaning of the simplicity. According to the KVL, this is a voltage. This must be a voltage, this must be a voltage, and this must be a voltage, yes? And we know that this what? The drop voltage, the total voltage is equal, the drop voltage across the resistance. And this one is what? This one is the voltage due to the rotation or the speed voltage, correct? Speed voltage. What about this one? D by dt of lambda q fast. This is what? This is a voltage due to static coupling, correct? This is the static voltage. Yeah. So now the transformation provide a useful description for the voltage equation. Each term has a meaning now. The first one here, although it's shared with the ABC, this one with the drop voltage actually the resistance, but this one in the ABC you cannot see, but here you can see. This is what? This is a voltage due to rotation. Yeah? This is what? This is a voltage due to static coupling. So for example, in the transformer, you cannot see this one because in the transformer, the stationary circuit and the rotor are fixed. There's no rotation. There's no relative rotation in between. So in the end of the day, all the voltage is due to what? To static coupling, let's say. Yeah? Yes. The same thing here. Huh? This term is what? This term is the speed voltage. And this term is what? Is the static voltage. Yeah. So until now, this arbitrary reference frame, which means that until now, omega is unspecified. So here, omega until now is unspecified. So that's why we call this one the arbitrary reference frame. So this one is called the arbitrary reference frame. Good. Now, the most common reference frame which means that now I need to specify omega. So this is the most common one, which is an arbitrary reference frame. Now here, if omega is equal to 0, this means the reference frame is not rotating, and this is called stationary reference frame. And if omega is equal to omega r, this is called rotor reference frame. Which means that the frame is attached to the rotor. And lastly, if omega is equal to omega e, or sometimes we call it omega s, this is synchronously rotating reference frame, which means that the reference frame is rotating by a synchronous speed. The most common reference frame in the induction machine are the number 2 and the 3, which is the stationary reference frame and the rotor rotating reference frame. Now, if I need to model the machine, the induction machine in the QD reference frame, I need also to consider the rotor circuit, RL circuit in the rotor. Until now, here what? This is the voltage equation for what? For a stationary circuit, RL circuit in the stator, yeah? So now, let's see. Let's try to find the equation of transformation for rotor circuit. Now, it will be the same if this one is A of S, and simply let's assume that I'm having the rotor. This one is AR, and the rotor is rotating by which speed? Omega R speed. And let's assume that this is the BR, and this is the CR. Now I need to establish a frame. Let's assume this is the QR, and let's assume that this one is the DR, and the same thing until now. Let's assume that this one is rotating by the arbitrary reference frame, omega R, and I need to find the transformation matrix. I need to find the transformation matrix. Now the angle from here to here is what?
Theta R.
Theta R, thank you. And the angle between here and here is what?
Theta, arbitrary theta.
Yeah, thank you, theta. And the angle between here and here is what?
ثيتا ناقص ثيتا R.
Theta minus theta R, thank you. Let's assume it's beta. Yeah. So now if I need to find the transformation matrix such that given the FABCR dash, which is the KR, I need to find the FQD0R, and also I need to find the inverse of the transformation. So which means that given the FQD0R, I need to multiply it by KR inverse in order to find the actual signal FABCR dash. And now I need to write KR and KR inverse. KR equal to what? Now, if you notice, equal to what?
KS نفس ال KS.
Yeah, but instead of theta, I will use what?
Beta.
Yeah. Do you remember? This is the angle between the reference frame, huh? So instead of theta, I would use beta. So this will be the cosine beta 1, cosine beta 2, sine beta 1, sine beta 2, 1 over 2, 1 over 2, 1 over 2. What about KR inverse?
نفس الشيء.
So simply I would say that KR inverse is equal to KS such that theta go to beta. Yeah.
Yes.
So this will equal to cosine beta sine beta 1, cosine beta 1, sine beta 1 and 1, cosine beta 2, sine beta 2 and 1. Yep. Yeah.
Yes.
Yeah.
Good. So now if I need to write the voltage equation in the for the RL circuit. So let's assume that I need to write the RL circuit voltage equation in the rotor. Who will help me with that? VQ D0R dash will equal to RR dash IQ D0R dash, then
Omega. Omega, right?
Okay, I will write it in general form, then we will discuss. Plus d by dt of lambda q dr dash, and the same thing I will define this one, which is the lambda dq r dash to be equal to lambda ds minus lambda qs and 0. Now here what I should put?
Beta.
Now in the stationary RL circuit, what I put it here?
Omega.
It was omega. The omega was the differentiation of what?
Beta.
The angle between the frames, huh? The angle between the frame. So here, the angle between the frames are what?
Beta.
So this will be the d by dt of beta, correct? Yeah, and d by dt of beta is what?
Omega R.
Do you remember beta? Where is it, beta? Let's see. Where is it? This beta. So beta is equal theta minus theta r. So d by dt of beta will equal to what? Omega minus
Omega
r. So simply now I'm ready to write the voltage equation in the DQ reference frame for the inductions for the symmetrical induction machine, omega minus omega r. Good. Okay. Do you have any question here? Do you have any question?
No.
Okay. So due to certain reason, I have something. I will end the lecture now. Okay. Now after, I think at after 30 minutes, you will have a quiz in the e-learning. Good. Okay. Before ending the lecture, do you have Any question?
دكتور
Yeah.
بس بدي أسأل مش بهالمحاضرة يعني عادي.
عادي.
دكتور هلا لو كان معطينا سؤال إنه لمدا 1 يعني ديبنت إن I وثيتا فور إكزامبل ولمدا 2 وكانوا مش لينير.
اوكي.
هلا الأوميجا اف والأوميجا سي ممكن يطلعوا زي بعض ولا بكون في خطأ بالحل؟
It can be, by the way, let's recall I lambda curve. And let's assume that this is the magnetizing curve, which is nonlinear. Huh? Now, let's assume that this one, if happen to be this space equal to this space, then omega f will equal to omega c. But in general, I'm telling you that omega f not equal to omega c where in the nonlinear system, but for linear system, omega f must equal to omega c. Understood?
Yes.
Yeah?
Yes, thank you.
Okay. Any other question?
دكتور بس برضه شغلة في المحاضرة الماضية لما حكينا عن السكويرل كيج والويند روتر.
Yep.
هلا كيف بس التوصيلة بتكون في حال كان سكويرل كيج والروتر نفسه يعني؟
Now, in the squirrel cage, you know that I don't have actual winding. In the squirrel cage, what I'm having bars shorted by rings. So here I'm having bars, and those bars are shorted by a ring. So this is bars, 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 and bars. So in the squirrel cage system, I don't have actually winding. Yeah, I'm having a solid, yeah, a rotor, which consists of bars, and those bars, it's like a cage, and those bars are shorted by the two terminals by a ring. So those are the same point, huh? So this can be seen as a 1 point, by the way, because all are what? Shorted by a ring. This bar and this bar and this bar and this bar shorted by a ring from this terminal and this terminal, which means that the rotor here is enclosed. You cannot access the rotor. You cannot connect any circuit to the rotor. But the wind rotor, the rotor has slots. In the slots, we have winding. The winding is uniformly distributed in space to form a three-phase winding. The winding, later on, we can take it to a slip ring. Those here, we have a slip ring, which means that I can connect external circuit to the rotor via the slip ring. Yep. Did I answer your question?
بس دكتور بالفيزر دايجرام كيف بدي أعملها للروتر للويند روتر؟ برسم كويلز كمان يعني بحط بالسكويرل كيج بعملهم شورت سيركت.
Now the same thing if you have the phase A, phase B, and phase C. Now let's assume what you are connecting a voltage. If you are connecting a voltage, then this is a voltage. If you are connecting a voltage here, this will be a voltage. If you are connecting a voltage here, so this will be a voltage. Yeah. If you are connecting an external resistance, yeah. So those terminals, you can access them, which means that here you can connect what? Here you can connect external resistance, let us. Good?
تمام دكتور.
Okay. You have any other question?
لو سمحت أسأل. هسا احنا اشتقينا للسكويرل كيج صح؟ عملنا ريفيرنج للروتر من الروتر للستاتور بناء على انه سكويرل كان.
No. If you look to the equation VAR, VBR, VCR was equal to 0 or it was arbitrary? It was arbitrary.
Zero.
No, it was the voltage equation. It was arbitrary.
Yes.
The voltage equation was arbitrary. Yeah.
Yes.
So this one is arbitrary for any machine, which is either squirrel cage or wound rotor.
Okay.
Now, if I'm setting this one 0, this will be what? The squirrel cage. Good.
Yes.
Okay.
طب
What else?
دكتور، ايش فكرة انه انا اعمل اكثر من فيز؟ يعني احنا اشتغلنا على الاي بي سي، ممكن حكيت بالمحاضرة الماضية انه ممكن اعمل 5 فيز، بالتالي الستيتا بتصير 72. طب ايش الفكرة يعني؟
Now you know that more phase, more power. More phases, more power. Now the single phase system, for example, has two shortcomings. Single phase system has two shortcomings. The first one, there's no starting torque. And the volume per torque is small, which means that if I need 1 horsepower single phase, if I compare it to 1 horsepower 3 phase, I can find the 3 phase is more compact. Yeah. So this means that if I can design a machine to be 5 phase, 7 phases, or whatever, in this case, what I will get? I will get more torque per unit volume. More torque per unit volume. The second thing, I will get reduced harmonic in the torque. Good.
Yes, هذا الشيء دكتور practical. عندي 5 phases.
Yeah, now before the revolution of the power electronics, it was not practical. Why? Because simply you don't have a supply that can provide you with 5 phases. Yes? But now, due to the power electronics revolution, simply you can design inverter which has 5 phases, 7 phases, or multi-phases system, correct?
Yes.
And in the end of the day now, most of the machine now use a variable drive system, which means that you are using inverter in order to regulate the voltage and the frequency. So now, yes, it's practical.
Yes, thank you.